Hello students, in this video we are going to make an epicycloid. So here is the question. Whenever you are going to make an epicycloid, you have two circles. The first one is the rolling circle and the other one is the directing circle. So let's understand the question. So circle of 50 mm diameter rolls means this circle is the rolling circle. On the outer circumference of another circle of 150 mm diameter. And this is the directing circle. Trace the locus of the points on the circumference of the rolling circle. For one complete revolution, let's understand this first off. We have to make a horizontal line, and this horizontal line represents the directing circle. In this case, it is 75 mm. After that, you have to find out the angle, the sector angle. The sector angle formula is small r divided by the capital R into 360 degree. In this case, the small r is 25 mm and the capital R is 50 mm. So 25 divided by 75 into 360. So it is 120 degree. Now from this point, make a line of 75 mm at an angle of 120 degree. After that, to make an rolling circle, so the circle radius is 25 mm and it is the directing circle. Basically, the circle will cover over here, rolls over the directing circle. So that's why it is called the rolling circle. Okay students, let's go into the question. Let's draw the question properly. So let's make a point over here. From this point, make a horizontal line and make a line of 75 mm. At an angle of 120 degree, we have already find out in the previous state small r by capital R into 360. In this way, the 120 degree line is drawn. After that, extend the line further up to 50 mm, which is the diameter of the rolling circle. Mark the point over here at the distance of 25 mm, which is our radius of the rolling circle, and make the circle which shows the rolling circle. Now divide the rolling circle into 12 equal parts. So how to divide into 12 equal parts? We can make an angle of 30 degree to 30. Now put your compass at the point O and open your compass from O to 12 and make an arc like this. So this represents the directing circle. Now in this circle, this rolling circle will roll over here to here. Now take the arc from all the 12 equal divisions like this. So far 11, then 10, then from the center. So this is the blue line which represents the center arc of the rolling circle. And then from 9, then from 8, then from 5, 7, 6. Take the protractor and divide this 120 degree into 12 equal parts. Now please remember that how many parts you divide your rolling circle, the same number, exactly the same equal of parts you have to divide your directing circle. And this is the condition. So in this case, it is 120 degree. So 120 can be divided into 12 equal parts, which means each division is going to be a 10 degree. So far 10 degree will make a line like this. Again further from 10 degree means 20 degree, and in the same way 30 degree. In the similar fashion, we can draw or we can divide this into 12 equal parts, which may be of 120 degree. And your line must reach up to the center arc of your rolling circle. Now represents this point, and this is from C1 to C12. all the intersecting points are marked from C1 to C12. Take the compass and open your compass equivalent to the radius of the rolling circle, which in this our present case the radius is 25 mm. And from here, which represents one curve which is seen, I mark here as an arc over here. It represents the first point P1. In the same way, take the compass, again put it at the C2 with the same radius 25 mm, draw an arc over a line on the rolling circle and mark the arc over here, which represents the point, second point, that is nothing but the P2. You can able to understand this. Now we have to do the same way for C3, C4, C5 and all other points. Let me take the point C3 and mark it with the same radius, mark an arc on the third curve which represents P3. In the same way we have to do for C4, which makes an arc here which represents the curve from the point 4. In the same way, put the compass at C5 and mark an arc that generates the arc from the point 5 on the rolling circle. In the same way, put the compass at C6 and mark up over here, and this represents from the point 6. In the similar manner, put the compass at C7 and mark an arc, C8 and mark an arc which represents the curve from the point 8 from the rolling circle, you can see here. And in the same manner, C9, C10, C11. I hope you understand how it is happening, how the arcs are being plotted. So we have a point of the epicycloid now. Just join using the free hand and you will be getting a curve. That curve is nothing but the epicycloid. Now we are going to make a normal, a line and the tangent line for the curve for the point 110 mm from the center of the directing circle. Here in this case it is given as 110 mm. So this is going to be the center of the directing circle, and mark an arc on the epicycloid at the distance of 110 mm. And now we have to join this arc with the center point, the rolling circle, and in this case the rolling circle is 25 mm, and mark an arc over here which cuts the blue line, that is the center line that was generated from the rolling circle. From this point we have to draw a line towards the center of the directing circle and it cuts over here. So from that point to the 110 arc point we have to join together, which was represented here in the form of green color. This green color line is nothing but the normal line of the given problem. Now we have to make a tangent to the normal. We have to draw a line that is perpendicular to the green line, which means the tangent. The purple color line is the tangent line. So I hope you understand this video. I have given it in a very simple and understandable